Okay, in this video, we are going to use our graphing calculator. We're going to use our graphing calculator in order to graph a piecewise function. So this calculator can be used in order to graph piecewise functions. It's a great way for you to solidify a correct answer. I don't like the graphing calculator 100% on this because it doesn't indicate well the critical points, but it gives you a basic idea of whether or not you're doing this correctly. And it also allows you to confirm a correct value or correct graph when it comes to an exam time or working on your homework or working on projects or so forth. So let's go ahead and pull out our calculators and we can go ahead and graph this function right here, this graph, this piecewise function on our graphing calculator. So if we want to do it, we're going to follow a particular circumstance. I don't know why the programming language works the way it does, but it does. So we just have to follow consistently every time. We're going to turn our graphing calculators on, and we're going to go to y equals 2, and we're going to type this entire piecewise function in one line, but we're going to do it in a very specific way. We have to input our function, our first function, which is going to be this value, which is going to be this guy right here. We'll call this the first function. He's going to be 3x plus 1, and we're going to put him in a set of parentheses. And now, directly adjacent to him, without using a sign, we are going to have to input his restricted domain. So we're going to do so using a set of parentheses as well. So we're going to hit parentheses, and we're going to click X, and now notice there's a less than sign. So in order to get to less than, you're going to have to hit second math. So I'm going to have my keys on here so that way you can see it. Second math, and option 5, I'm going to scroll down here to option 5, is a less than. So I'm going to scroll down here and hit enter, or you can just hit you're just going to hit 5. And now we're going to plug in a value of 1, and we're going to close our parentheses. So notice we have our first function in parentheses and then our domain in a second set of parentheses. Now we're going to add the second function. So this is going to be our second function. It's going to be our second function. So now when we do so, we're going to add in parentheses our second function x squared. And we're going to close this parentheses, and now we're going to restrict the domain of this function, and we're going to get our value of x, and now we have to input the greater than or equal to sign. So we're going to go back to second math, and we go down to greater than or equal to, which is option 4, and we're going to put in a value of 1, and we're going to close our parentheses. So this should be something of, let's go back, make something of what you have. Well, I hit graph, but it's graphing for us now. I'm just going to go ahead and put this into our large screen so you guys can see what you're supposed to have. So let's go ahead. This is what you should have on your graphing calculator. If you want, you can pause the video to make sure you have that in there. Otherwise, we'll go ahead and we'll graph this. And notice it gives us what we hypothesized before. Notice when I look at these values, remember, as we examine this was x is less than 1. We define this as being one of our critical points. This is one of our critical points because it is not specifically included. So if I were to hit trace and type in 1, notice it gives me a value of 1 because at 1, that's where our function is actually x squared. So this is our functional value that we're going to use. This is our function we're going to use when x equals to 1. But when x is slightly less than 1, I'm just going to hit over. Notice we get 3.72727272. In reality, it's going to be 3 times 1, which is 3 plus 1, which is 4. It doesn't actually get to 4, but I'm going to go ahead and zoom in just to show you. I'm going to hit zoom and go down to option 2 and hit enter. And I'm going to zoom in right here at this point. Normally, we would have to draw an open circle at this point, and that's one reason why I don't like the graphing calculator specifically, because it doesn't draw an open circle, it just stops it. So as I trace, and I get ever so close, I get very, very close to 4, but I never hit it, and as I get past, it drops down to my second function. So the calculator is not a perfect rendition of the piecewise function, because on paper we're going to have to use an open circle to denote a less than or greater than, and then we're going to have to use a closed circle to denote a less than or equal to or greater than or equal to. So let's go ahead and try graphing a piecewise function that contains 3 independent functions. So let's go ahead and try that. So we're going to take negative 2x when x is less than or equal to negative 1. We'll say 4 when negative 1 is less than x, which will be less than 3. And then we'll say 2x plus 1 when x is greater than or equal to a value of 3. So we could graph this independently by hand, but I'm going to go ahead and use our graphing calculator to show us how we can demonstrate this function on our graphing calculator. So let's go ahead and pull open our graphing calculators. So now when we put this in, I'm going to clear out my old one. I'm going to clear out my old, oh, where am I? There we go. I'm going to clear out my old one. So I'm going to type parentheses negative 2x, close parentheses. Now I type my domain, which will be open parentheses x second math less than or equal to, which will be option number 6, negative 1. So I've typed my first function, and its restricted domain in there. So go ahead and pause if you need to make sure you have it correct. Now we're going to add our second function. We're going to add our second function to his domain. So this guy is easy. It's just a constant function, so it's a value of 4. And be careful here. So be careful. When we enter his domain, there's no real way for us to write this in here like such. So we have to sort of trick the calculator. So we're going to write this portion, first. So I'm going to write negative 1 is second math less than, which will be option number 5. Option number 5 less than x. And then now I'm going to write this function. So I'm going to write this function, second. But I have to write this because really if I say negative 1 is less than x, which is less than 3, that's the same thing as me saying negative 1 is less than x and x is less than 3. So I'm going to go back to my second math option, and I'm going to right click over to logic, and notice it gives me that and. So I'm going to click on and now I'm going to type the second portion, which is x is less than second math less than, which is option 5, 3. And then I'm going to close this. So I'm going to go ahead and make sure we can all see this. So this is what the second function should look like. It should have that 4 as the function. And then we have to trick the calculator by writing the domain in such a fashion. And then now we're going to add our last function in his domain. So our last function is going to be parentheses 2x plus 1. And now I'm going to put in his restricted domain, which is going to be x is greater than or equal to, so we're going to hit second math. Greater than or equal to is going to be option 4, 3, and then we're going to close our parentheses. So now you should have something that looks like this. And once we have that, I'm going to graph this on my graphing calculator. Notice my graphing calculator doesn't really look very normal because I was actually using the same screen settings from the last function. So I'm going to go up to zoom and I'm going to hit standard, which is option 6. And now this will give me a magnification of a 10 by 10. So it actually will change up. So this portion is my first function, this is my constant function, and this portion is my third function. So I'm going to go ahead and just take a quick snipping of this graph here. And we'll put this into our notes to give an idea of what it's supposed to look like. So notice here, this is a negative 2x, this is a negative 2x, and that's this function right there. And then this function is the 4, so that guy right here is the function of 4. And this guy is the function of positive 2x plus 1. But the only thing now that we'd actually have to do is that we're going to have to be a little more specific on our graph. And we have to denote whether or not at these critical points we're including them or excluding them by using a closed circle or an open circle. So notice here for negative 2x, this will be when x is less than or equal to negative 1. So that means at negative 1, we're going to have a closed circle for my function negative 2x. For 4, at negative 1, we're just less than x. Negative 1 is just less than x. So this is going to have an open circle. And notice here, if we remember our vertical line test, a vertical line can be drawn vertically through our function, and it can only intersect at most one point. And notice that does not violate the vertical line test, so we know we still have a function. And then over here, we're going to have another circle at 3 that's going to be open because it's only less than 3. And then lastly, when x is greater than or equal to 3, at this portion of my third function, I'm going to have a closed circle because there his domain is included. That 3 is included because of the greater than or equal to symbol. So be very conscientious that we call them piecewise functions because they always will be functions. And you're never going to have an overlapping of points vertically. There's never going to be multiple values of the domain that correspond to more than one value of the range. So keep that in mind. Keep that in mind as you graph these guys, that once you transpose them from the graphing calculator, then you must be very careful and plot them on your own paper, remembering to identify the critical points that are included by using a closed circle or excluded by using an open circle.